4.4 Factoring Part 3. This is the final factoring video. Today we're going to be doing perfect square trinomials. Trinomials, again, is something that has three different terms. And then type 2 factoring, where the coefficient is larger than 1. All right, so let's get going. All right, perfect square trinomials. This is a shortcut you can look for, but be careful. Looks can be deceiving. What you might think might be a perfect square trinomial if you don't watch won't actually work, because there are certain ones that look like it, but they're not perfect square trinomials. Do not confuse these with the difference of squares, which starts out as a binomial. Binomial means it's only two terms. It only starts with two terms, and that's the difference between these perfect squares and the perfect square trinomials. Look for perfect squares with this perfect square trinomials. Look for the perfect squares at the beginning, the quadratic term, and the end, and that's the constant term. And the trick is it must have a positive constant, a plus in the back end, or it will not be a perfect square trinomial. Okay? Then check the linear term to make sure it works. That means check that middle, because sometimes it works, sometimes it doesn't. For example, let me change my color over here. That'd be good. All right, so x squared plus 8x plus 16. All right, this quadratic term is a perfect square. X squared can be split up evenly. All right, the constant term in the back, the 16, is also a perfect square. All right, if that's the case, then see if it'll work in this pattern. You take the square root of the x squared term, and you take the square root of the 16 term, and then you split it up into two binomials. All right, so split up the x's. All right, it has to be positive, because nothing in the polynomial is negative, so it must be all positive, and besides, the plus in the back means same sign, and this tells us they're both positive. All right, take square root of 16, which is 4, and 4. Now you want to check it. When you multiply this through, you get an x times 4, which is 4x, and another x times 4, which is 4x. Together make 8x. So yes, this does work. So x plus 4 will work. So this is a perfect square trinomial. All right, so then this, remember, if it's written same exact factors in both of them, then you can write that simply as x plus 4 quantity squared. And you'll see that a lot written this way. All right, now check your middle term again. Make sure that it must make 8x. This can be written, of course, as I just said, x plus 4 squared. All right, so now let's try the next one. Check the first term, the quadratic term. That's a perfect square. You can take the square root of 4 and x squared. The back end is a perfect square. You can take the square root of 25 and y squared. Both are perfect squares. All right, there is a plus in the back end. Okay, so that's another positive sign that we're on the right trail, but let's see if it'll work. We take the square roots, hold on. We take the square roots of both of those. All right, what signs are they going to be? It says same signs, and then we look right here, they're both going to be negative. So it's negative, negative. All right, so I can take the square root of the first term, the quadratic term, which is 2x. And 2x, whoops. And then I'm going to take the square root of 25y squared, which is going to make 5y and 5y. All right, now we must check to see if it makes 5x when we multiply it out. Well, when I multiply this, I get 2x times a negative 5y, which makes a negative 10 xy. Right, and then I multiply the middle. Negative 5y times 2x makes another negative 10xy. They do not make this middle term. So this is not a perfect square trinomial. Okay, this did not work. Even though it looked like it was going to, it did not make that middle term. So that's what I mean when you have to check to see if it works, because when you split this one up, it did not make this one. So this one is not a perfect square trinomial. Okay, so this does not work. All right, so check those. It's a trick you can look for, but if you don't catch those, that's okay. We can still do it other ways. All right. Finally, the factoring type 2 trinomials, where the coefficient is greater than 1. Okay, you need to be very good at doing these, so you need to practice these. There are several different things you need to remember, and we have to factor these a little bit different. You always need to remember to GCF first, if you can. Okay, that's true for any type of factoring problem. That is the #1 rule. Then you want to multiply the quadratic term, which is the first term, with the constant term, which is the last term. You will be looking for numbers that multiply to give you that product. So whatever you get when you multiply the first and last term, whatever you get, that's what you're going to be looking for, numbers that multiply to. The sign rules still apply, so if you've memorized those, you will be well above everybody else. What you will be doing with this type of factoring problem is rewriting that linear term, which is the middle term. Okay, so you're not changing the basis of the equation or the function, but you're just going to be writing it so you can work with it. And that's what math does a lot. They just rewrite things so they can solve things. They manipulate things so that you can use them. So you're going to be rewriting that linear term and make it into 2 smaller linear terms. You will still have a variable in each one of those, and you'll see what I'm saying in a minute. And then you're going to finish factoring by grouping. Okay, so because you're going to end up with 4 terms, so you'll finish up with grouping. All right, so notice our first example, 7x squared plus 16x plus 4. All right, so we have a coefficient bigger than 1, so we must use this type factoring. All right, so you're going to multiply the quadratic term and the constant term, and that makes 28. So you're looking for factors of 28 that add to be 16. So I put add to be 16 over here. Okay? So you're going to be looking for those factors. 1 and 28, they don't add to be 16. 2 and 14, yes, they do. So those are the ones we're going to be using, 2 and 14. All right, so then you're going to rewrite your linear term. Now notice what I did. I went ahead and filled this out for you. You rewrite only the middle. So you bring down the quadratic term, that stays the same. See? Same thing as this. And you're going to bring down the constant term. That did not change. You're just rewriting the middle. So instead of having 16x, I can break that down into 14x plus 2x, or 2x plus 14x, whichever way you want to do it. Okay, I just happen to write 14 first. So 14x plus 2x, that makes the 16x. Nothing else changed. Then you follow your grouping rules, where you group the first 2 terms and you group the second 2 terms. All right, you GCF. All right, between 7x squared and 14x, I can take a 7x out. That leaves me with x plus 2. Between the 2x plus 4, I can take a 2 out, which leaves me with 2, and outside my GCF and x plus 2. And remember, with grouping, you want these parentheses to be the same, and they are, so you know you're on the right trail. Then you just bring down one of the ones that's duplicated, bring it down, and then put your leftovers together. And that makes the 7x plus 2. And this is completely factored. You can check it by distributing and see that it works. Okay, you can do this with any type factoring. If you even want to do this with type 1 factoring, which I don't recommend because it's a lot more work, you can do it. But I just recommend using this only if it's a coefficient bigger than 1, or you have grouping anyway. So you have to do it that way. But this is the way you want to do it. And you need to be really, really good at this kind because they use it a lot. All right, and that is all that's on the notes. We're going to be doing lots of practice in class. If you have any questions, come see me. See you then.